This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2017 AP Calculus exam, free response question AB4 BC4. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I am a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors, and where appropriate, I'll present some very specific scoring examples. In this contextual problem, a boiled potato is taken from a pot on a stove, and we're given the initial internal temperature of the potato. In addition, the internal temperature is modeled by a given differential equation. In Part A, we need an equation for the line tangent to the graph of h at t equals 0. And then we need to use this equation to approximate the internal temperature of the potato at time t equals 3. In Part B, we need to use the second derivative of h with respect to t to determine whether the answer in Part A is an overestimate or an underestimate. And then finally in Part C, we're given another differential equation that models the internal temperature of the potato. And we need to solve this dE, and that is to find an expression for g of t, and use this model to find the internal temperature of the potato at time t equals 3. Here are the scoring guidelines for this question. Part A was worth 3 points. 1 point for finding the correct slope of the tangent line, 1 point for presenting an equation of the tangent line, and 1 point for finding the approximation using the tangent line. Part B was worth 1 point. This was for correctly stating the answer in Part A is an underestimate and for providing an appropriate reason using the second derivative of h with respect to t. Part C was worth 5 points, generally for solving the differential equation and for finding g of 3. This is a pretty typical distribution of points in this type of AP Calculus free response question. 1 point for separating the variables, 1 point for the antiderivatives, both antiderivatives here, 1 point for including the constant of integration and for using the initial condition, 1 point for reaching a point in the solution process with an expression in both g and t, and 1 point for the final expression for g of t and for finding g of 3. Note that the student can earn a maximum of 2 out of 5 points if they don't introduce a constant of integration at the appropriate point. And if there is no evidence of separation of variables, then they cannot earn any points in this part. Here are some brief comments about student performance on this question. First, this was a contextual problem and it was pretty wordy. The phrase internal temperature appeared 7 times. Some students struggled to understand and incorporate all of the information that was given in this problem. Students had to use a differential equation in each part of this question, and some struggled with the calculus necessary in each part. The variables in this question were a little different. Instead of x and y, students had to use t and h, or t and g. Specifically, in Part A, there was some confusion about the independent versus the dependent variable. In Part B, many students didn't use the chain rule, and some used local arguments in trying to argue about the sign of the second derivative of h with respect to t. And in Part C, unfortunately, there were separation errors, and some students did not include a constant of integration or introduce this constant too late in the solution process. The first point in Part A was for finding the slope of the tangent line. The student didn't need to provide any supporting work, just the slope. And once this point is earned, it's in the bank. And that means that they cannot lose this point. The slope can appear without a label, or it can even be mislabeled. And here are some examples that would earn the point. Note that in previous years, m equal to minus 16 would not earn the point because we were looking for evidence that the slope was obtained using the given differential equation. The slope, minus 16, can also appear as part of a correct tangent line equation. Each of these examples would earn the first 2 points, one for the correct slope, and one for the correct equation of the tangent line. Note that even though there are some unusual combinations of variables here, in each case the student has conveyed the slope and a correct equation of the tangent line. The second point in Part A is for an equation for the tangent line. If the student uses a slope different from minus 16, they can still earn this point if their line passes through the point 0.91 and the slope is clearly labeled as either dh dt or dy dx. Here are some specific examples. In the first two, each equation is correct, with the correct slope. So each earns the first 2 points. In example 3, the slope is incorrect, but it's labeled as dy dx, and the line passes through the point 0.91. So the student earns 0.1 here, but they're not eligible for the third point. Similarly, in example 4, the student has an incorrect slope but labeled, and the line passes through 0.91. In example 5, the student has labeled the incorrect slope only as m equals 16. They don't earn credit for the tangent line equation, and they cannot earn the third point. The third point in Part A was for the correct approximation using the tangent line equation. And the approximation symbol isn't necessary to earn this point. Here are some specific examples. Example 1 is very succinct. The slope is given and labeled, a correct tangent line equation is presented, and the correct approximation is also given. The student earns all 3 points. Example 2 is even shorter. Remember that we don't need to see the slope given explicitly or separately. Here it is part of an equation for the tangent line. So this response also earns all 3 points. In example 3, the student presents the correct slope, but never writes an explicit equation for the tangent line. But they do present the correct approximation. So this response earns 101. In example 4, the student has the correct labeled slope initially, but makes a mistake in the numerical simplification. This error comes off the last point. Since the tangent line goes through the point 0.91, this earns 110. In example 5, the student has an incorrect slope, but labeled correctly. They earn the tangent line point, but cannot earn the third point. This response earns 010. Part B was worth 1 point for stating that the answer in Part A is an underestimate and for providing an adequate reason. Now the reason here required 2 items. The student had to present the derivative of dh dt, and here are some common expressions for this derivative. And the student needed to include a statement that this derivative is positive. The student did not need to appeal to a specific interval nor discuss concavity to earn this point. Some common errors here included, well, first, stating that the answer in Part A is an overestimate, or presenting an incorrect expression for the derivative of dh dt, or presenting a local argument concerning the sign of the derivative of dh dt. In Part C, the first point was for separating the variables. And here are some specific examples. In the first two cases, the student has successfully separated the variables. Note that the -1 can be on either side of the equation. Each of these expressions earns the first point. In example 3, the student has not earned the first point yet. The differentials are not present, so we can't be sure if they have correctly separated the variables. In example 4, we interpret this as a correct separation of variables. The student earns the first point. In example 5, the student has actually separated the variables and found the correct antiderivatives in one step. They earn the first 2 points. And example 6 illustrates a case of no separation of variables. This student earns no points in this part. The second point in Part C is for the correct antiderivatives. The student earns 1 point for 2 correct antiderivatives. Or, and this is a little fuzzy, for 2 consistent antiderivatives after an honorable attempt at separation. And here's the format for an honorable attempt at separation. The general philosophy is that a student has not dramatically changed the complexity of the antidifferentiation. Note that in an honorable attempt situation, the reader must check the antiderivatives to see if they're correct. The third point in Part C is for including a constant of integration and for using the initial condition. There is an eligibility criteria here. The student must have at least one antiderivative correct or consistent. The constant, plus c, must be explicit, and the use of the initial condition must be reasonably clear. And just a reminder, if there is no constant of integration at the appropriate step, the student can earn a maximum of 2 out of the 5 points in this part. The fourth point in Part C is for an equation in G and T. And I interpret this as an equation in G and T on the way to solving explicitly for G. This equation can be explicit or implicit, but it must be correct or consistent with the student's antiderivatives. If the equation is implicit, it must be of this form. And if the equation is explicit, it must be of this form. The last point in Part C is for an expression for g of t and for the value g of 3. The expression for g of t must be explicit, and it must be correct or consistent. So the student must report the value of g of 3 to be 54, or their consistent g of 3 based on their g of t. And this value must be between 27 and 91. And this makes sense given the initial condition and the statement that the internal temperature of the potato is greater than 27 at all times t greater than 0. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. And there is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There's material there involving technology and calculus, there are classroom activities, and lots of calculator tips and tricks for test success.